All right, guys, so this is our lesson on parametric relations and inverses. And we're going to start by talking about parametric relations on the xy axis. We're going to say that parametric relations on the xy axis are functions or relations that defines the x values of its ordered pairs with equations defined by a third variable, t. And we're going to say that t is what we call the parameter. Now, in general, what are we talking about here? So we've got either a function or a relation, basically meaning that we could have every x value paired with only one y value for a function, or we could have x values paired with multiple y values for relations, right? So these are going to be graphs that don't necessarily pass the vertical line test. And when we're looking at these equations defined by a third variable t, basically what we're saying is we would take that parameter t and plug in values to equations that give us the x and the y values of our ordered pair. So right here we might see something like x equals k of t, and k of t would be some equation defining the x value, y equals g of t would be some equation defining the y value, such that for any t we have k of t, g of t as the ordered pair on the xy axis for a value of t. So let's go ahead and graph a couple ordered pairs. I'm going to graph two ordered pairs, and then I'll let you guys go through and get the rest of this table. So right here we've got parametric equations defining x and y values that we're going to graph on the xy axis. We're going to evaluate ordered pairs for the given t values we've got right here. And then plot the ordered pairs we get for those t values on the xy axis. So right here, plugging in -1, we can see that when we plug in -1 to our x equation, we're going to get -3. When we plug in -1 to our y equation, we're going to see we're going to get 5, and that's going to give us the ordered pair -3, 5, which we would then graph on the xy axis right there, -3, 5. Plugging in 0, we're going to get -2, 0. So -2, 0 is the ordered pair landing us on the x-axis right there. And what I want you guys to do is to go ahead and just get some practice with this. Go ahead and plug in the rest of these t values into our two parametric equations to get the x and y values that are going to come together to give us our ordered pairs. So why don't you guys pause the video and give that a shot, and we'll come back and look at this in a second. Okay, so right here we've plugged in t values from 1 to 5, and we've gotten x and y values giving us ordered pairs over here that we've graphed. For the t value of 1, we get the ordered pair -1, -3. For the t value of 2, we get the ordered pair 0, -4. For the t value of 3, we get the ordered pair 1, -3. And for the t value of 4, we get 2, 0. T value of 5 gives us 3, 5. And we graph those ordered pairs right here. Now, it appears that what we have is the graph of the parabola if we sort of connect all our ordered pairs right here. And in fact, we can graph parametric equations on our calculator. If we go to the calculator and go to mode, we can go down. When we're on the xy axis, we're in the function mode. If we go over to parametric, then right here we are going to be graphing parametric equations, right? And so right here we can go in and go to y equals, and now we've got an equation to enter for x and an equation to enter for y. So entering our two equations, we have right here the x button is going to give us the variable t, so we would have t -2 for the parametric equation defining x, and right here we can go ahead and type in t and then squared, and that would be -4t for the parametric equation defining y. And if we press graph now, we're going to see the graph of that parabola that we just sort of got the ordered pairs for on that previous page. Now, in general, parametric equations are used to define shapes on the xy axis. So a lot of times they'll give an interval for t value. So we won't be plugging in every single t value and getting all the ordered pairs that get this parabola. If we were getting a set of parametric equations that gave us, say, a circle, we wouldn't want to continue to define ordered pairs around and around the circle. We would generally give a parameter for t. So right here, if we just used from -1 to from and including -1 to, let's go over a little bit, to and including 5, we would only see the graph of the parametric relation from the t values of -1 to 5, which are the ordered pairs -3, 5, and 3, 5. So right here, going into our calculator, we can modify our parameter for t by going to Window, and right here we can say we want to see only from -3 to 5. And when we graph right here, well, looks like it's given us a little bit more than we thought. Let's see, let's go back. Y equals, and then right here we said oh, I'm sorry, it was -3, it was -1, wasn't it? So -1, and right here we graph again, and we're seeing just that piece of the parabola. And again, this is because most of the time when we're graphing using parametric equations, we're getting shapes, not necessarily just functions. So right here, finding an algebraic relation between x and y is generally going to mean determining y as a function of x for us, right? And so basically what we're going to do to get an equation that would give us this graph right here from our parametric equations is we're going to take our parametric equation for x and solve for t, right? And then we'll be able to plug in what t equals with x into our y equation, and then we should get a function, should get y as a function of x. So right here, looking at this, we're going to say we've got x equals t minus 2. We would add 2 to both sides, so plus 2 and plus 2. And that would give us x plus 2 equals t. And then right here, we would plug that into our parametric equation for y. So right here, we've got y as t squared, and then right here, minus 4t. So we've got to plug in that x plus 2 in 2 places. So right here, that'll give us y equals, and then right here, we've got x plus 2 squared minus, and then 4 times x plus 2. Simplifying this, we can get x squared plus 4x plus 4 minus 4x, and then minus 8. And right here, if we combine like terms, we're going to end up with y equals just our x squared when our positive 4x and negative 4x cancel. So x squared, and then right here we've got plus 4 minus 8 gives us minus 4. And right here, what we can do is take this equation up to our xy axis and see that in fact we do have the graph of y equals x squared minus 4, that parabola moved down 4 on the y-axis. Right here, what I want you guys to do is to find an algebraic relationship between x and y for our 2 parametric equations right here. So again, what that's going to mean is solving for t with our parametric equation defining x, and then plugging that back into the y equation to get y as a function of x. Okay, so pause the video and give this a shot. All right, guys, so right here, taking our parametric equation defining x, we can go down and solve for t, which is going to give us t equals our x over 2. And then right here, we can take that t equals x over 2 and substitute it in for t in our y equation, which is going to give us 3 times x over 2 minus 1, which simplifies down to the linear function y equals 3/2 x minus 1. Okay, so that's the end of this first video. We're going to go through and talk about inverse function relationships in the next couple videos. Okay, so see you in the next video.